In this problem, we're being asked to use implicit differentiation to find y prime for this equation. And once we find that derivative, we're going to evaluate the derivative at the point 2, 4. So being asked to differentiate implicitly means we're going to find the derivative of this equation as it's written. We're not going to do any algebra to rearrange it. I'm just going to take the derivative of the left side and the derivative of the right side as it's given. And being asked to find y prime here, they're assuming we recognize that y is a function of x, but I'll go ahead on a test and give you this extra notation. So later, when we're taking the derivative, if we end up with an x prime, we'll see that, oh yeah, x is the input variable. The derivative of a plain old variable is just a 1. So we'll replace any x primes we get with a 1. And if we end up with a y prime, we'll recognize that y prime is a function. So we're just going to keep that y prime notation. Okay. So let's take this derivative implicitly. Now the traditional notation, again, is the fractional notation. So I would indicate I was taking the derivative using the d of dx notation because y is a function of x, but I'm going to use the prime notation like I did in class. So I'm going to indicate I'm taking the derivative of the left side and the derivative of the right side using this prime notation, and I'll continue using prime notation. So let's start here. Let's take the derivative of this first term. I see 2 letters in this term. I see an x and a y. The x is a variable. The y is a function. They're being multiplied. So I need my product rule. I'll do my work off here to the side. My first factor is x squared. My second factor is y. So I'm take the derivative of the first factor, just power rule, same 4 steps as always. Drop the exponent down. Rewrite the base, decrease the exponent by 1, multiply by the derivative of the base. But here, the understood exponent of 1, we don't want to write that. It can get confusing. And x prime is just 1. So when I multiply by 1, I'm just going to end up with 2x. Okay, and then when I take the derivative of the second factor, the derivative of y is just y prime. Y is a function. It doesn't get replaced with a 1. So now I'll do my product rule. That's first times derivative of the second plus second times derivative of the first. So that'd give me x squared times y prime plus y times 2x. Okay, so that's the derivative of the first term. Now I move on to the next term. The derivative of 3x squared. Again, that's just power rule. 4 steps. I drop the exponent down. I'm going to multiply with the coefficient. So 3 times 2 is 6. I rewrite the base. I decrease the exponent by 1, and I tack on the derivative of the base. But again, understood exponent of 1, we don't write that. And x is a variable, so x prime just crashes in for a 1. I multiply by 1, I get 6x. Okay, the next term is a constant, so the derivative of a constant is 0. And then on the other side of the equation, again, I just have a constant, so the derivative of that constant is 0. Okay, so that's my implicit derivative. But remember, we're being asked to find y prime. So I need to isolate this y prime. Now I'm just going to do algebra to get that y prime alone. But I can clean this up a little bit before I start doing that. In this first group here, my x squared y prime, I'm just going to rewrite that x squared y prime. I can't do very much with that. In this next term, I can reorder the multiplication. I can put the coefficient 2 first and then write my letters alphabetically. Side by side, they're just being multiplied. I'm subtracting a 6x. I don't need to write this minus 0, but I do need to write that it equals 0 because it's an equation. I have a 0 on the right-hand side, so I need to show that it's equal to 0. Okay, so now I'm just going to focus on getting this y prime alone. So the first thing I need to do is move these 2 terms to the other side of the equation, right? So I will add 6x to both sides of the equation, and I'll subtract 2xy from both sides of the equation, and that will leave me with an x squared y prime on the left and a 6x minus 2xy on the right. Okay, and then I just have to divide by x squared to get that y prime alone. So there we have it. Y prime is equal to 6x minus 2xy over x squared. Now, technically, I can simplify this. You might recognize that there's a GCF of x in the numerator that I can factor out, and that would divide off with one of the factors of x in the denominator. So if you wanted to go that extra step to factor, that's great. My math lab might require you to do that. I won't require you to do that on a test. I'm happy if you stop here. These are equivalent. These are equivalent expressions as long as x doesn't equal 0, because we can't divide by 0. But we're told up here we're going to evaluate at this point. We need to plug in x equals 2 and y equals 4. So let's go ahead and do that. So we found y prime. That was one step. Now we plug some stuff in. So what is the derivative under these conditions? I just have 6 minus 2 times y, which is a 4. And then we're dividing by x, which is a 2. So that'd give me 6 minus 8 over 2. That's negative 2 over 2, which gives me a negative 1. So that's what y prime is equal to under those conditions. And again, if you had plugged in the x equals 2 and the y equals 4 to the unsimplified y prime expression, you'd get the exact same answer. So I'm just going to show you that real quick. I'm just plugging it in. Okay, so what would that give us? That would give us 12 minus 16 in the numerator. So that's a negative 4 in the numerator. And then, oops, that's a square down there. 2 squared is 4 in the denominator, and negative 4 divided by positive 4 is negative 1. So we ended up with that same value of negative 1, whether we use the simplified expression for y prime or the original expression for y prime. If you would like to see me find the derivative implicitly using the fraction notation, please don't hesitate to ask, and I'll make a video for that.